The polar form of a complex number. Similar to vectors, complex numbers have two forms, rectangular or Cartesian, and the other form is polar. Complex numbers, we can usually write this in polar form as r bracket cos theta plus j sine theta. It's also common to see this r cos theta plus I sine theta. Or we could do it like a vector, r angle theta. If you have your complex number z, which is a, the real part, plus j, b, the imaginary part on an Argand diagram, this is z, and a is the real part or the x-axis, this length, and b is the vertical or imaginary part. So to work out your r, which is its magnitude, r, again we just use Pythagoras, as we did in vectors. A squared plus b squared square rooted is the magnitude r. Theta is your argument. This just means angle of a complex number. Argument, it could be arg z or just theta. It's anti-clockwise from the origin, same as vectors. So this we just do with the inverse tan of b over a. Remember, vectors we used y over x. Complex numbers we use imaginary over real. We have 3 plus j4, and we want to convert this to polar. So we work out r using the square root of a squared plus b squared. A is 3, so this is 3 squared, b is 4, so 4 squared. So this is the square root of 9 plus 16. Square root 25, 5. R is 5. Theta is the inverse tan of b over a. So theta is the inverse tan of 4 over 3. (53.1 degrees). So we write our polar form of our complex number 5 angle 53.1 degrees. Convert 2 plus j5 into polar form using radians. That's the same system. R is Pythagoras, so it's 2 squared plus 5 squared, just the a and b, squared and square rooted. 4 plus 25 is the square root of 29. We can leave it like this. And theta is the inverse tan of 5 over 2. Work this out on the calculator in radian mode, which is 1.19 radians. So we write our number as root 29 angle 1.19 radians. That's our complex number in polar form. This time -3 plus j4 is not in the first quadrant. It's handy to draw a sketch. -3 plus J4 is actually in the second quadrant. -3 up 4. So our angle is between 90 and 180 degrees measured round here. Come back to the angle. Work out R. -3 squared plus 4 squared is 9 plus 16. So R is √25 equal to 5. Theta is the inverse tan. It's easier this time not to put the negative in the calculator, just to do inverse tan of 4/3, and bear in mind that it has to be in the second quadrant. So if we do this in degrees, we get 53.1. degrees. That's the angle in the first quadrant. So we have 53.1 in here, in the red angle. To get the second quadrant, we must do 180 subtract 53.1. So therefore, theta is 126.9 degrees. And we put it together, our angle theta is 5 angle 126.9 degrees. Next one is -2 subtract J4. Draw a diagram to work out if it's in the first, second, third or fourth quadrant. -2 subtract 4 is down here. -2 subtract 4. So that's the third quadrant. R equals -2 squared plus -4 squared. 4 plus 16. So this is the square root of 20. Now we work out our angle, inverse tan. Easiest not to put the negatives in the calculator. 4/2. Just use 4/2. So inverse tan of 2, 63.4 degrees. So we know the third quadrant, we have to work it out using 180 plus 63.4 degrees. So this is 243.4 degrees. Now by definition we should not use this angle because it's too large. We have to use numbers in the range -180 up to 180 degrees. So in order to get a number in this range, we can just subtract 360 from 243.4. So write a note, subtract 360 degrees to get it back in range. 243.4 subtract 360 is -116.6 degrees. So this is the angle we use to finish. Final answer is √20. I'll just write it back at the top. √20 angle -116.6 degrees. Four subtract J7, also not in the first quadrant. This is in the fourth quadrant, 4 along and 7 down. So r, do this in the same way. 4 squared plus negative 7 squared. 16 plus 49 is root 65. Angle, use inverse tan 7/4. And this gives us 60.3 degrees. Again, this is in the fourth quadrant. So we usually do 360 subtract 60.3 degrees for the fourth quadrant answer. However, this is 299.7 degrees. It's too large. To take this back within range of negative 180 to 180, we just subtract 360 from 299.7. Subtract 360, and that gives us negative 60.3 degrees. That's the angle we use. Final answer, root 65, angle negative 60.3 degrees is our polar form of the complex number.